To anything. Oops. I bet I just turned off the wrong thing. Let's see what I got here. Okay, good. All right, so let's do this. First of all, here's what they have. They have three equations for them. The first one they call, well, I guess they don't call it, but it is, general form. Y equals ax squared plus bx plus c. Okay, so many of your quadratics or second degree polynomials will look like this. All right, where a, b, and c are some sort of real number. Okay, then there is a vertex form. Y equals a parentheses x minus h squared plus k. And then there is a factored form. Y equals a parentheses x c1 x minus c sub 2. Okay? So those are basically the three forms you're going to see these in. All right? So they're either going to be in general form, vertex form, or factored form. All right? So that's what they're going to kind of look like. And what I'll do is throughout the whole day, or whole time we're here, is just kind of show you each one, and we'll talk about them and explore them a little bit, and so you'll get a feeling for which one is good for certain things and which ones are not. So let's start off with the graph, and let's look at general form first. Okay, so unfortunately I can't connect, so I'm going to have to do it this way. So I'm going to disconnect here. Turn that off and go here. All right, so I'm just going to type, I think I'll do this, y equals, and if you want to follow along, you can. All right, that's up to you. I'm going to go a x squared plus b x plus c. So a, b, and c, we're going to add sliders to those. All right, and we're going to play around with those things and see what happens. All right, that's the goal here. So this would be a quadratic, right? We're going to get a U-shape, and the graph of the U-shape is called a parabola. All right, so the graph of a quadratic is always called a parabola, and I'll spell it out for you and stuff if you're not sure how to spell it. That's what we get. The reason why they spend a lot of time on parabolas is because they model a lot of motion, right? So anything that is curved like this, which is called projectile motion, is modeled by a parabola. Okay, so many of your sports motions, as far as basketballs and baseballs, footballs, all that stuff, all that is all modeled. Track and field, same thing. Is all modeled by some sort of projectile motion. I mean, bow and arrow, you can think of anything has that sort of a motion. Okay, And then also they say that the arc is one of the most appealing shapes. All right, so that's why you see a number of different arches and how nice they look. Also, bridge supports, okay, are also many of them parabolic. All right, so if you see like a number of times you'll see a bridge and it'll be supported like that. And the reason is because it's not because it's appealing in what it looks like, but it's straight. Okay, so then it has this bridge shown to have a lot of strength, so it's been able to support a heavy bridge. Okay, so parabolas and triangles, that kind of a shape always is able to do a lot of the support. Okay, so that's why they spend a lot of time on them. Okay, versus the other things. So here we go. We're going to change this around. So I'm just going to check and hit the play button on A, and you can see that we're going to get this. So there's a U, okay, and there's a U, and we can see that A is definitely changing the graph, right? So let's pause it here. So what is A doing to change? How does changing A affect the graph? What's happening? Changes the width of the parabola. Okay, changes the width of it. Awesome. Did anybody see anything else that it does besides that? Yeah.
Once it turns negative, it flips the parabola upside down.
Once it goes negative, it flips it upside down. All right. So when we have, like Bree was saying, look, so then as this A gets larger, it's changing the, you said width of it, right? Is that what you said? Okay, width. Okay. And Ronnie says, well, once I make it negative, it's going to go upside down. Okay. It looks a little distorted in here because of this A making it wider. All right. And a lot of that has to do with B. If I was to make B 0, then it would be a little bit better. All right. So you can see it better there. So that's what A does. All right. And we'll record this. Don't worry about it if you're frantic and writing it down or something. We'll write it all down. Okay. So that's what A does. All right. I'm going to make A 1, and then we'll play with B a little bit here. Now, B is a hard one to figure out because it looks like a lot of things are happening, right? It looks like the width of the parabola is changing. It looks sort of like, but in reality, the width is not changing. But something, you see kind of what's happening with when B changes?
Changes the position on the x-axis.
Yeah, it's changing the position a little bit, isn't it? Okay. So, and it's kind of strange how it's changing. If I was able to trace this point, I bet it changes it in another arch sort of fashion. Okay, so that's kind of weird. All right, but that's what's happening with B. B is really hard to get a notion of what it does as far as how it changes the position of the graph. So in this case, all right, it's really hard to see what B does. So we don't really say too much about that, except that we know that it's going to change the positioning of the graph. It didn't matter whether it was negative or positive, all right, it's still always opening up. It's just that when it's positive, then this point here is on the negative part of the graph, and when it's negative, we know it's on the positive part of the graph, right? So that's kind of what B does. So I want to make B a positive 1. Actually, I think let's make it back to 0. I like that better. All right, so that's what B does, even though we don't have a real sense for it, and that's okay. C, though, we can easily see what's happening with C. What's C doing to the graph? Yeah, it's moving it. It's moving it. In which direction? Horizontal or vertical? Vertical. Yeah, if I focus on this point, I can see that it's moving up and down. And not only that, But if I take right here and stop it, C is 2, and I come in on this here, right, what point that guy right there is 2. Okay, so if I move this up to 3, 4, 5, all right, I can see that not only is it moving it up, but I can also figure out what that y-intercept is. Same thing when it's negative. All right, so that's what that does. So now I'm going to kind of zip back over here and write some of that stuff down. Okay, so for a general form, A, we said change the width of the graph. So when A increased, when it got larger, what happened to the width? Did it get larger or did it get smaller? You remember that part?
That's smaller.
That's smaller. So when A increases, the width is smaller. Now when A is between 0 and 1, so it's a fraction less than 1, then the width will increase. And when A is less than 1, or less than 0, sorry, then that's when we're going to get to flip. Okay, so we have A changing the width of the graph. So as A increased, the width is smaller. All right. When A is between 0 and 1, our width's going to increase. All right. And when A is less than 0, it's going to flip over the x-axis. Now, this whole thing here that we're talking about in here, okay, is called a vertical stretch. So basically, all right, if we take, this goes back to sort of some geometry ideas. All right, so you could take a triangle or any shape, and you can stretch it, all right, either vertically, horizontally. We can make it bigger, we can make it smaller, and we can move it. All right, those are called transformations, and that's what we're doing to these equations. Is we're stretching them vertically or horizontally, all right, moving it left and right, or moving it up and down. All right, so that's what's happening to these things. So A is basically a vertical stretch. All right, so we got that part figured out. Then the B part. Okay, so B was one that we really couldn't tell a whole lot of, except that when it was positive, right, it was over on this side, it was over on the negative side, and was negative, it was over on the positive side. All right, and it made kind of a U shape when we changed it. Okay, so I'm just going to say, I think Melinda said just changed its position. Changed position on the graph. Okay.
Doesn't it actually move the vertex of the parabola on the path of the negative?
Yeah, we haven't mentioned that word yet, but we're going to, yeah. Okay. So it's changing the position of the graph. All right. So again, in this form, B is kind of ambiguous. It's just kind of hard to get a handle on what it does. All right? It's not that easy to see that. And that's okay, because we'll look at those other forms and then we'll get a better feeling for some of this stuff. All right, C. C we did get a pretty good feel for. Do you remember what C did?
Moves the graph vertically.
Yeah, moves parabola vertically. And then I'm going to put down here that was the y-intercept. Okay. So there's our A, B, and C in that situation. Okay.
So the y-intercept when b is 0, right?
Yeah, when B is 0. Okay, so we have some stuff about general form. All right. And let's leave just a little bit of space here if you're writing stuff down, because we're going to add something, but I don't want to do it right this second. All right, so let's take a look at the next form, all right, which is vertex form. Let's take a look at that one. Y equals A times X minus H squared plus K. All right, so now I'm going to have to take this out. There we go. So I'm going to get rid of this, and this, and this, and this, and type it in here. Y equals A parentheses X minus H parentheses squared plus K. And if you want to follow along, you can. And there it is. And so I can add sliders for those. All right. Now, as Miles was saying about the vertex, so right here, all right, where this curve bottoms out, okay, that particular point is called the vertex point. All right. If A is a negative number, then it becomes the highest point, all right, the top, all right, and that is called the vertex. So the vertex is where that U shape begins to change from one part of the U to the other. All right. So there that is. So again, if I play A, look at that. Oops, come on, play it. All right. It doesn't change what we had before. A is still going to do the same thing. All right. It's called a vertical stretch. Flipping it, making it wider, narrower, just like Bree says. That's what it's going to do. All right. Nothing different there. I'm just going to leave A back at 1. There. H, though, we can easily see what H does. What is H doing? Yeah, it's moving it horizontally. Okay? All right, so that's easy to see. All right. And if we look at the equation, we see that it's X minus H. Okay? So the H is affecting the X because it's X minus H. They're grouped together. So it kind of makes sense that, okay, it's going to change in the X direction there. Okay, let's pause this one. I think I'll make it 0. Just so you can see things a little bit better. There we go. And we'll play the K. And what does K do? Moves it which direction? Vertically. Okay? Very similar to C. All right? Very similar to C. Okay, so here's another nice thing about this, though. If I make this 2 and we make this 5, right, and I click on my vertex, what's the vertex equal to? 2 and 5, right? Okay. Notice what the H and the K are. All right. So the h and the k are 2 and 5. So if I change this h 5 and this k 2, click. Notice again, right? H is 5, 5 and 2. Thus the name vertex form. All right? So this equation form tells you what the vertex is. Right? It tells you what it is. And that's what's nice about this one compared to the other one. Because if you have something written in vertex form, this is an easy sketch of a graph. You know what the vertex is, and you just look at the A and you can sketch it. Okay? Whereas the other one, because of that B, it's hard to tell. But vertex form is great. The only trick part to this is up here where it says it's x minus h. All right? And h is 5. So when we have x minus 5, we would think that maybe the vertex is negative 5, but in actuality, it's the opposite. So if I come over here and make this x h a negative 5, all right, now my vertex is here, but in the equation, it would be x plus 5 because of negative and negative. So you have to kind of watch for that. And then in this sense here, it's always going to be the opposite because it's in the form x minus h. Right? The k is okay. That one doesn't make much difference there. All right? So that's vertex form. So now I'm going to go back in here. Okay, put this in. And write this out. So here's this. So A does the same thing, just this vertical stretch in the flip, which we call a reflection. No change from what we had before. H, which way does H move it? Moves horizontally. And K moves which way? Vertically. And it's called vertex form because the vertex is H and K. All right? Now, if it was up to me, I'd like all these parabolas to be in this form because I can tell a lot about these. I can find the vertex, I can sketch it, I can do a lot, all right, with vertex form. Okay? I like this one. Okay, we're done with that one. All right, let's take a look at the last one, which is factored form. Y equals A times X minus a C with a sub 1 and an X minus a C with a sub 2. All right, so that's what we're going to look at now. All right, and then we'll just go through and do a whole bunch of other little things on 6.1 that you need to know. Okay, I'm going to plug this here. Go back to this. Get rid of this. Alright. Y equals A parentheses X minus. Now I don't, let's see, I'm going to go C. I don't think it likes if I put a 1 there. Yeah, I guess it does. Okay, and parentheses X minus C. A little 2 there. And all of them. Alright, so now, again, here's my equation, X minus C1. This is factored form. If I play A, guess what? Nothing's going to change. Okay, so what's neat about this is that A is always the same. It doesn't matter what form it's in, A does the same thing every single time. All right? That's the good thing about A. Right? A does the same thing every time. So I'm just going to stop it here. Let's go to 1. Stop. Okay. Now, C1 reminds you probably a little bit of what B was doing. And C2 really gets this thing going. All right? So you might want to say, well, what? So this isn't helping us at all. But let's do this. Let's make this, yeah, 3 is good. And we'll make this, make it a negative number, 1. So if I click on these things, -1 and 3. Oh, -1 and 3. So let's make this 4, 4, -1. Well, here you will still see it. 1.9, negative, and 4. Now we see what the C's do, right? Now I can see, because if I make this one over here to be a 5, -5 and 4. So those are your x-intercepts, all right? So every one of those forms pretty much gives you a little bit of a sense of the graph, except for general form, all right? It's just not very good for graphing. This one tells you what the x-intercepts are, right? A is going to do whatever it does. So those are your 3 forms, okay? And your quadratics are always going to be in one of those 3 forms, right? A here again doesn't change anything. Vertical stretch. Okay, and a reflection over x. And C1 and C2A are x-intercepts. Okay. Can you find the vertex by looking at factor form? Does it tell you what the vertex is? No, it doesn't. You can kind of find it, all right, but it doesn't give it as readily as the other one does. Okay. So those are the 3 forms, all right. Questions on those 3 forms? So, what kind of things are they going to ask you to do?
Are we adding something to B?
Yeah, we're going to go up to that general form and add a few things. Here's what they're going to ask you to do. First thing. Find the vertex. Okay? They're going to ask you, and I'm going to ask you. All right? So it wouldn't, in fact, probably a test question is going to be something along the lines of, here is a parabola. I want you to tell me what the vertex is. I want you to tell me what the x-intercepts are. I want you to sketch the graph. I want written in vertex form. Something along those lines. Okay, so you're going to get one, and it's going to ask you to do this, do this, do this, do this, do this. All right, so let's find the vertex first, because that's what it's going to ask us to do. How do we do that? There's 2 ways. What do you think one way is?
Put it in vertex form.
You could put it in vertex form. What's another way? Yeah.
Negative B over 2A.
Negative b over 2a, which I haven't talked about yet, but obviously he knows it. Okay, good. What's another way? Yeah, graph it. Put in decimals, graph it. Right? I mean, you can. So we can graph it, okay, and find it. Click on it, figure out what it is. All right? And then negative b over 2a. So negative b over 2a will always tell you what the x-coordinate is of the vertex. I'm going to leave that blank. Negative b over 2a will work. Is negative b over 2a going to work when it's in vertex form? No. You don't need it. It tells you what it is in vertex form. All right. Will negative b over 2a work when it's in factored form? No. No. So the only time this is going to work is when it's in this form. Okay. All right. Good. I'm glad we figured that out. All right. Let's do it then. So here's how it goes. A, B, C. So vertex, negative b, so that's negative 4. 2 times a. A is 1 because there's just one x squared there. So that's 2. All right, which is negative 2. Now the question is, I got to find the y-coordinate because the vertex is a point. All right, it's not a number, it is a point. So now I got to find y. But here's the good news. If I know what x is, can we use this equation to find y? Yeah. Yeah. So we plug it in. Okay. Now remember, you can use decimals too, and I'm not going to tell you which way to do it. All right. You just got to get an answer, and you can. But you know, it's always that thing. We used to tell kids, well, if you're on a deserted island, you know, you don't have a calculator, oh my gosh. But here, you know, if you don't have Wi-Fi connection, decimals isn't going to work. So you got to do it by hand. Let's see. 16, so it'd be negative 12. There it is. All right. So negative b over 2a will work, all right, if you want to do it that way. And we're not dismissing putting it in a vertex form. It's just we're not ready to do that yet, all right? So those two ideas will work, okay? Here we'll try another one, same thing. Find the vertex. Y equals... I'll put a number out in front this time. 3x squared plus 8x plus 20. This will be a fun one. Here we go. All right. So we're going to find the vertex. Okay. I could graph it, right? But we'll use negative b over 2a. What's b in this case? 8 and a negative 3, so we have a negative 6 there, comma, don't know, got to find the other part. 8 over negative 6. I can probably change that a little bit. 4 over 3 negative. Alright, so now I got to stick that nasty number in there.
Should it be positive? Because it's negative b.
Oh, yeah. Thank you, thanks, Miles. Good job. Here we go. So we're going to go 4/3 squared plus 8 times 4/3 plus 20. That's definitely calculator time right there, right? I don't know if this is going to, I don't already see it's not going to work. Let's see. Okay, plus 32 divided by 3 plus 20, except that that's going to be a negative. Rats, I forgot about that. Anywho, let me get rid of this. This calculator thing does not work very well. 3 negative times parentheses 4 divided by 3 parentheses squared equals that plus 32 divided by 3 plus 20 25.3, anybody else working out get the same thing? Hopefully you did. Guess I can check it. I'm pretty sure it's going to be a pretty high number.
Yeah, that's what I got.
Is it? Sweet. Okay. All right. So negative b over 2a is pretty slick. I mean, you know, it's not bad. Of course, you can graph it and be done in about half the time, right? But it is there. And, you know, I think it's good that you know how to do some of those. Just that's what you do. Let's see. Then they're going to ask you to do this more on the vertex. Okay, find the vertex. They're going to ask you to find something called the axis of symmetry. Graph it, evaluate it. How about that? We'll do that too, I guess. Sketch a graph. And I don't know. They have you do some of these, so I'll put them on here. Now, all of these, let's do some of both. So they have some in vertex form and some not. All right, so here we go. We'll do some that are in vertex form and some that are not. Just so you get that. So there's that one. Okay. So we're going to find the vertex. Again, we could graph it, but we'll use negative b over 2a. B is negative 5. A is 1, so it's going to give me a 2. Okay. And this time I do have the sign right. So I have negative 2.5. I'm going to make it a decimal. And I don't care if you put a decimal or a fraction. You know, last one we did a fraction, but it doesn't really matter. All right. So let's see. Good, this one doesn't matter. So 2.5 squared plus 5 times 2.5 minus 117.75. Okay, there's the vertex. All right. So they want us to do that. So we did. Hopefully you guys got the same numbers I did. Like I said, that calculator is not that great. All right. Axis of symmetry. So, first of all, it's really hard for me to graph because it's not in a very good form. But I do know the vertex, so let's see. Negative 2.5 back this way, 17.75, which is here. Okay. So I'm going to get this kind of a look. All right. How do I know I'm going to get that kind of a look? Well, A is positive, so I know it's going to be aiming upwards. And it's not real big, so it's not going to be very narrow. And it's not decimal, so it's not going to be real wide, so I just sketched. All right. There it is. Oops. Yeah, so I got that. Okay, sketched it. Now, the axis of symmetry, that's what I'm trying to really get to here. Axis of symmetry, right down the middle. Okay, right down the middle. Because parabolas are symmetric. Okay? They're symmetric. So then this is called the axis of symmetry. Okay? Rarely used, but people like to ask about it. Well, math teachers like to ask about it. So the axis of symmetry, I'm just going to call it the axis here, is going to be a vertical line, so that's x equals, and right through that vertex point. Okay? So that's how you do the axis of symmetry. All right? You just go to the x coordinate of the vertex, there it is. All right? Sketch the graph already, and then they want me to know what f of 1 and f of 4 is, so you guys, you know, you can do these. We're just going to plug those in and figure them out. All right. So this is going to be negative 5. and f of, and I just picked these numbers because they picked some numbers too, so I just said okay. $16, $36, $35. Right there and there. So there have a bunch, some questions like that. I probably wouldn't ask that type of stuff. Like I said, I'm more interested in vertex, x-intercepts, sketch the graph, write in vertex form, and we'll do all that too today. So, but this is what they're asking, so we'll do it like that. Okay. Questions on that part? Let's do one in vertex form. Same thing. Find the vertex. Okay, axis of symmetry, and f of 1 and f of 4, I guess. All right, here we go. Vertex form. Y equals, put a 2 out in front, x plus 1 squared minus 3. All right, first thing is, this is so nice because I can do the vertex faster here than I could with Desmos. What's the vertex going to be? Be careful on it though. -1 and -3. All right. Again, because, and it's so tempting, just put a 1 here. I'm going to see it happen. This is a +1, so I'm just going to put a 1 there. But no, remember, it's x minus h. So since it's a minus, h has to be a -1 to make that a plus. So it's actually -1, and then the -3 doesn't matter. All right. So that's so nice because now I can go -1, -3. All right. And then 2, well, it's going to be a little thinner than normal. All right. And opening upward. There it is. There's my sketch. All right. Okay. That's done. So I did this. Axis of symmetry. X equals, nice vertical line going right down the middle. So what's the equation for that? X equals -1, very good. Okay. And then f of 1, that doesn't change. Right? You just put it in there. Let's see, 1 plus 1, 2 squared, 4. 2 is 8, and should be a 5. And all we're doing is just putting this in here, right? Working it out. 5, 10, 7. Okay. All right. So, vertex form, like I said, I like it because I can, look all the, I did the vertex and the graph and the axis of symmetry in probably a minute. It's just so easy to use.
47.
Oh, what did I get? 47? What's 47?
5 squared times 2.
5 squared is, so that's 25. Oh, times 2, yeah, thank you. I meant to put a 4 there. I just had the 7. I was going to put it, I think it didn't show up on the tablet, and that's what it was. Okay. Anyhow, so that's how that works. Okay. The other things they're going to have you do, all right, and then I'm going to give you a break here, is find the maximum and minimum. They talk about a maximum and a minimum. But here, let's look at this. Okay, it doesn't really matter where the axes are. If this is a parabola here, all right, and this is my vertex right there, that's my maximum value. I can't get any higher than that. All right, and the same thing's going to happen here. If we have a parabola that looks like this, then my vertex here is the minimum. So guess what? If it asks you to find the maximum, you go find the vertex. And that's all you got to do there. Okay? Now, there are some folks who accept the maximum minimum as being the y value. I like it to be a point. All right? So like on your quiz that you take next week, you know, if you give me the y value, I'm probably going to say the vertex is a point. Okay, that's just one of my things that I think that the vertex is a point. Thus, I think the maximum and minimum value should be a point. Okay, so make sure you tell me the x and the y. All right, when you do that. But I mean, I could do an example of that, but you're just finding the vertex, so it isn't any different than. And you seem to be pretty good at that part. Okay. All right. That is all of 6.1, which is a lot of stuff, but that's what it is. Any questions on any of that? And you'll be hammering through that section anyway when you do your homework time. So, okay, let's take our converting from one to the other. So let's do that. This is the one thing that was not in Math 65 if you took that beforehand. Converting general to vertex and vertex to general. All right, so basically that's what it is. They're not talking a whole lot about factored form until 6.3, but let's do the easiest one first, okay? So we're going to convert vertex to general first because that's the easiest one. So let's say we start off with 1, okay, looks like this, all right, minus 1. And we're going to convert this to ax squared plus bx plus c, all right? Not sure why we want to do that. Okay, because this tells us about the graph, tells us the vertex, I can do everything, but they kind of want us to be able to do it. Okay, not very difficult really to do because we know when we have x plus 3 or anything for that matter, okay, squared, if I'm going to what is called expand that, all I need to do is write it twice because that's what squaring means anyway. Okay, so if I have something squared, I just got to write it twice. And now we're just going to FOIL this. Plus 3x, oops, plus 3x plus 9, okay. So if we wanted to convert from vertex form to general form, that's what we would do. Okay. So yeah, on it, you know, a test or a quiz question could be, all right, if it's in vertex form, write it in general form. But all you're doing is kind of just algebraic simplification or expansion or whatever you want to call it. You just basically writing twice and FOILing. If I stick a number out in front, that doesn't really change much. I'm still just going to do this. Always going to write this twice because that's what squaring means. And then just FOIL it. Now I'm probably going to FOIL these first. Minus 3, so I'm going to cut that step out a little bit. Follow my order of operations, right? So squaring, powers first, exponents, okay? Did that, multiplication, and then addition and subtractions. Good old order of operations. And there it is. Okay, so again, all we're doing for converting from vertex to general is just taking and using some x minus 3 squared. I write it twice because that's what you should have been told to do. Whenever you see this, you write twice. FOIL, distribute the 2, throw in the 1 at the end, and it's done. And that's it. All right? So that's pretty straightforward. All right? Again, I don't really have a practical purpose for why I would want to do that, but it's something they're going to ask you to do. Okay? Let's do the other way, which is definitely a little bit more complicated. So if we're going to go from general to vertex, and again here we might say, well, why would we want to do that? Well, again, because vertex form is so much easier, all right, than general. It tells me a little more about the graph, tells me the vertex. Yeah, I can do it with general form, but vertex form, well, it just gives me a little bit more information. Okay, so let's pick out one of these things. So we're going to write this in vertex form, okay? Which means when we're done, it's going to look like this. So in other words, we're going to kind of go backwards from what we just did, right? So that's what we're going to do. Now, there's a technique to do this, all right? And the technique we're going to use is something called completing the square. Completing the square is also used to solve quadratics, although it's probably the poorest way of solving them. All right. You know, I have a good friend of mine who teaches with me, and we've talked about this. I say, why would everybody want to use completing the square to solve a quadratic? Because it's just a poor way of doing it. However, it is a good way of converting from general to vertex. And if you take further mathematics courses, it'll come up a couple of other times in those subjects. So completing a square does have a purpose. It's just not very good for solving quadratics, although they sometimes use it. Okay, how does it work? Well, it's an algorithm, all right? And it has a sequence of steps. So the first step in completing a square is to move this constant out of the way. All right, and at first, I'm going to tell you that you're probably going to go, huh, what are we doing here? All right, and it's going to be a little confusing, but once you get those sequence of steps down, you'll be able to go through it pretty well. So, we're going to move this over to this side. That's our first step. So now we have that. Okay. What we're going to try to do is try to create this x minus h squared. Okay? We're trying to create this. So this x minus h squared, remember, came from here. All right? And you don't have to write this down if you don't want to, which comes from here. All right? That's where that comes from. Okay? So what we're trying to do is create. We're going to go from here to here to here. So we're going to work backwards. And here's how we do it. So first we got rid of the 5. Get it out of there. It's in the way. I don't want it. Now we're going to take this number and we're going to take half of it. All right, so we're going to take half of that number, which is 2. I like to write it up here and circle it. Now, that's me. All right, I've been doing that for a long time. But you don't have to. That's just one of the crazy things I do. Now I'm going to take that number and I'm going to square it. Okay, that's why it's called completing the square. I'm going to square that number, and so I'm going to add a 4 there. Okay. Now, if I just all of a sudden say I'm going to take half of this, square it, and add 4, I just can't add 4 to one side without adding 4 to the other side. You just can't. You know, the equation isn't balanced if you don't do that. So now I'm going to add a 4 over here because I have to do that. Okay. Now look what happens. X plus 2 squared. All right. And you know what happens? Whenever I teach this, somebody always says, what happens to this 4? Where did it go? Well, where it went is we rewrote this whole thing here. We just rewrote this in a different way. So we rewrote so that we have x plus 2 squared means I have x plus 2 times x plus 2, which means if I FOIL, I end up with the exact same thing that I had. Oh, there's the 4. Okay? So all we're doing is taking and rewriting this in this form. Nothing's going away. Nothing's disappearing. It's just being rewritten. Because I want that. I want x plus something or minus something quantity squared. Now we can go back. Almost there. Now we go back to this. Okay? So I have a 4 minus 5. That's going to give me this. And then move that 1 over back over. And now we have vertex form. Okay? Notice one of the things that I kind of mentioned that may have not regulated exactly, but A is 1, A is 1. The A's are always the same thing. Right? It doesn't matter which form, A is always going to be the same thing. Right? So now you can find the vertex, you can make a sketch, you can find the maximum or minimum depending upon what it is by changing it to vertex form. Okay? But you use a technique called completing square, yeah. Yeah.
Like you just add it?
This 4 here? Yeah, the completing square is a sequence of steps. All right, the first step is to move this 5 and get it out of the way, because it's in the way. All right. Second thing is you're always going to take half of this number, all right, which is 2, and you're going to square it, always. 2 squared is 4. And the reason is because you want this to be what we call a trinomial, so we want it to be so I can write it in this case, in this form. Okay, so by taking half of this number and squaring it, I get that. Okay, so
Why don't you make it 7 number? Like 7.
Maybe this is a 7?
Yeah, why do 7 instead?
Well, let's do a 7 one then. You want a 7? We'll give you a 7. Okay, here you go. Y equals x squared plus 7x. Here, let's make it minus. Minus 7x plus 8. How's that? All right. Watch what happens. So, we're going to move the 8 out of the way first, right? Always move that thing. Get it out of there. It's in the way. I don't like it. All right? So now what's our first step? What are we going to do? Take half of that number, right? 3.5. Okay? Now, some teachers might say, oh gosh, no, it's 7 over 2. All right. But I really don't care if it's 3.5 or 7 over 2. All right. Okay. So, what do we got to do with this number? Square it. Right? We got to square it. 3.5 is squared. I don't know what 3.5 squared is. Let's see. 3.5 squared. 12.25. Okay. 12.25. But remember, if I add 12.25 to this side, you got to add it over here. Right? So you got to keep those equations balanced. So now I got to add that over here. 12.25 equals. Now I'm ready to go. X parentheses. This sign always drops down. If it's a minus, it's a minus. If it's a plus, then it's a plus. There's my circle number. It's always going to go there. And now we move that over. So, if I did this correctly, then my vertex should be 3.5, comma, negative 4.25. You know, axis of symmetry, maximum, minimums, I can do all that stuff now. So you just deal with it, right? Doesn't change anything. Let's try another one, because, like I said at first, this is like, what the heck? Y equals x squared. But we'll make them even. 12x minus 3. Okay, what's our first step? We're writing this in vertex form. What are we doing first?
I'm going to add the 3 to the other side.
Get that 3 out of there and move it to the other side. Now what are we going to do?
We're going to add 36.
Okay, but I really don't want to skip that step. So we're taking half of 12 and squaring that. Yes. All right. Where else is that 36 got to go? On the other side. Okay. Got to balance the equation. So this is an algorithm, you know, and I've been trying to do a lot of conceptual stuff with you, but I can't with this because it's just an algorithm. You just follow, sequence of steps. Okay, here we go. X. What's going to go right here? First, we got to put a plus, right? Whatever that is. Okay, if it's minus, it's minus. If it's plus, it's plus. Okay, plus and 6. Very good. Notice that every time the number that I put in there is the one that I circled. Okay, 2, 2, 3.5, 3.5, 6, 6. Okay, I know what to put in there. All right, let's figure this out. So we got 39 on this side. I'm going to move it over. Some vertex forms actually will look like this. Okay, I've seen it like that before. Depends on the textbook. I kind of like writing it like that. Okay. So there it is. All right. That's called completing the square. All right, and that's how you convert it. Okay. All right. Question? Yeah.
The 6 is just, I think we already covered it, but the 6 is opposite. So when we get a positive, it's going to be a negative.
Because remember, it's x minus h. So it's the h that you're putting in there because it's a minus. That's what messes it up. All right. Any other good questions on that? Oh, we did 3 of them. All right. Here's a better. Karen asked a good question. But here's another one. It's not so much that when this is an odd number, it's what happens when we have an a. Because then that messes everything up. We don't have an x squared here, and that was easy. But now that we have a 2 there, now that messes things up a little bit. So we have to kind of change it just a little bit. How are we going to do it? First, same thing. Get that 9 out of the way. It's messing me up. I'm going to move it over here. Now, if you go to the Math Learning Center and you ask somebody to do this, I bet they're going to show you a different way than what I will. But I think my way is easier, so. All right, if you want to go to the Math Learning Center and ask them. I don't know what Khan does. I can't remember how he does it, but here's how I'm going to do it. So, I want to get rid of that 2. I don't want it there. So, I'm going to divide everything here by 2. Okay? And the reason being is because now I have this. Okay? Notice that I didn't divide anything over here by 2. I left it alone because I'm not interested in that part. This is the one I want to fix. So I divided by 2. Why? Because then now what do I have here? Yep. Right. And if this was a 5, what would I divide by? 5. Yeah. Okay. So here we go. Now I'm going to do the exact same thing I've been doing. All right? I'm going to take half of 4. Square it. Got to add it to this side. Okay, got to do it to that side. Can't just add something to one side. Going to rewrite this, x minus 2 squared. Okay? Got all this junk over here. Alright, so now I have that. Okay? So really, we haven't done anything much different. We just divided. So now that we divided in that second step, we're going to multiply by 2. Because we're going to undo the division that we did here. Alright? We're
How
just
did
going
the
to...
8 turn into a 4?
What's that?
The 8 turn into a 4.
Because I took
Oh.
8 and divided it by 2.
Sorry.
So now we're going to multiply everything by 2. So watch what happens. Here we're going to get 8. Here, this 2 and this 2 are going to cancel. So see, that's why I didn't divide anything. Because I knew ahead of time that I was going to multiply by 2 because I've been doing this for a long time. So there's no reason for me to divide that. I'm just going to multiply it anyway. And now this 2 is going to slide out in front of that. And that's done. And look at that. It's just like what we had before. Alright, so we have a y. I'm going to combine these two. This goes here. Remember what I said. The a's are always the same. Okay? And if we go back to that original equation, you'll see that we had an a of 2, and look at that. We still have an a of 2. Alright, the a's are always going to be the same. So the only thing that changed is this very first step right here, the second step, where we're dividing so that we can get an x squared. Alright? And then I just got to multiply it through. The 2 just sticks right out in front of that because it's an a. You always want to make sure you take 2 times this number. This is always going to cancel out here. And then it works. Okay? Like I said, you know, other people are going to show you a different way. It's just that the way they write it is different. But you get the same answer, it's just different. Let's try another one. Same idea. This time we'll put a 3 out in front. Okay, so there we have one like this. Alright. Again, I don't want that 8. I want to get it out of there. Alright. What are we going to divide by now? 3. Good. We don't want 3x squared. 3x squared is messing us up. So divide it. Get rid of it. X squared plus 4x. Alright, so here again, I'm taking the 12, dividing it by 3. Okay, so I get 4 here. That one I do want to divide, or else I messed up the whole problem. The left side we don't care about. Okay. Oh, it's 4 again. Rats. Alright, half of 4. 2, right? Got to square it. Add it to both sides. What's this going to be? The right-hand side rewritten as what? X plus 2 squared. Outstanding. There it is. 2's all over the place. Okay. I got this junk over here. Alright, there it is. To finish the problem, we're going to multiply everything by 3. Look at that. There's a 12. Okay. Don't worry about that because the 3 is going to go away. I get a 3 out in front. A's are always the same. I don't know why I put a 2 there. You already probably knew that that wasn't right. That's going to go there. And then combine those two. That's going to be 4. Get that 4 and move it to the other side. There we go. Vertex. Negative 2, negative 4. Sketch. Negative 2, negative 4. 3 is going to be a little thinner than usual. Okay. There it is. Axis of symmetry, right down the middle, -2. You can answer any question you want. All right. So that's what they're going to have you do in this section. I looked it over, and they're really, we've covered a lot of this stuff already, because it talks about what the A does, what the vertex does, comparing one thing to the other. Really, I didn't see anything in there that is going to mess you up. I see, well, we'll do a couple of those, but I want to do one more converting here, and I promise this will be it. Y equals, this time I'm going to put a negative in front. Alright, in fact, let's just make it sort of simple. Negative x squared, 5x. We'll do another odd one, so I know Karen likes those. Okay, there we go. So now we have this. Alright, and again, we still have a problem here because we don't want a negative x squared. We just want x squared. So, got to get rid of the 10 first. It doesn't really matter what we do there. That doesn't change. But, what are we going to divide by? Yeah, -1. Nice. So I divide by -1. Again, I'm not interested in dividing that. Don't care. The only thing I got to be careful of here is to make sure that I divide not only the x squared but also the 5 here. I'm going to divide both of these things. So that's changing it, flips it to a positive. And now I just do the exact same thing that we did before. Half of that, square it. I know what 25 squared is. Add it to this side. Okay. Rewrite it. X plus 2.5 squared. Okay. This number always goes there, always does. This sign always drops down there. And then we'll multiply by -1. Okay. So this is a -6.25. This thing doesn't change because we're just dividing, undoing the division. Negative sits out in front. You can put a 1 there if you want. Doesn't matter. Look at it, 16.25. Move it over there. There we go. Okay. So if you have a negative, divide it. Get rid of it. Do the same thing. So that's the completing the square algorithm. All right. Step, step, step. It's always the same steps. That's why it's an algorithm versus something that we would do conceptually. All right.
So then the vertex for that, since we have a -1 as A, would the x coordinate be 2.5 then?
No, it's always going to be,
It doesn't matter.
this is just your A,
The
right?
power would be flipped.
Yeah. A is going to flip it, right? So it's going to be upside down. Good question. Yep, vertex is going to stay -2.5, 16.25. It's just that, let's see, -2.5, 16, so it's going to be something like this. Probably going to open up down. All right, complete a square. Like I said, it's not at first glance. It's like, I'm not sure about it. But then after a while, you'll get better at it. You keep doing it, doing some, and then you do about half a dozen, you'll have it down. Okay. You're just going like this. You don't have questions. Okay. Any questions on the completing a square? I'm just looking at 6.2. There's a couple problems early on where they have you complete the table, but that's just, you'll be able to do that. You're just plugging numbers in there. They have some questions. One here says, sketch the graph, identify the vertex. Again, we've already done it when it was in general form. and it's in vertex form, it tells you what the vertex is. We've already done that. And then it says compare the graphs. So, they do. Here, let's do this. For example, I'm just going to do 26 just for the heck of it. Y equals x minus 2 squared minus 3. Okay. This is on page 441. If you want to look at it, you can. I'll tell you what's going on. Okay, so it says here, sketch a graph. So sketch. That's what it says to do. Sketch. Vertex. State. Transformation. All right. You can sketch it. You can do the vertex without even having to do a whole lot here. What's the vertex of this thing? 2 and negative 3, right? Great. 2, negative 3. Look how, I'm not even getting very precise. I'm just going 2, negative 3. All right, it's just a sketch. Okay, A is up. A is positive. It's going to be up. There it is. Okay. Sketch, vertex. Easy. You can do it. All right? You can do it. State transformation. Here's what they're asking you to compare it to. They're asking you to compare that graph to this graph. All right? And this is y equals, or f of x equals, x squared. They're saying compare those two graphs, state the transformations. What are they talking about? Here's what they're talking about. How do these two graphs compare? What has happened to the purple graph in comparison to this one? Well, what has happened to it? Where did it go? Yeah. So it's on. So no, you said it pretty well. So it moves to the right, and then down. Yeah. That's what you're going to say. So you're going to say moved. I mean, you could say it however sophisticatedly you want, but Roddy said it well. Says it moved this way, and all right. So, okay. So he said it moved right. How many units did it move right? 2 and down 3. There you go. That's the transformation. Okay? So we call this a translation. It just moves horizontally and vertically. But we talked about that when we did the sliders a little bit about what that does. Okay? If let's say same problem, except we put a 1/3 in front of this. So now we do this. All right? So sketch it. Let's find the vertex first. What's a vertex? Oh, don't let it throw you. What's the vertex? 1, 0. Yeah, 1, 0, right? There's nothing going on with K. 1, 0. 1, 0. There it is. Oh, I got a 1/3. So what does that tell me about this thing? Which way is it opening? Up. But it's kind of...
It's going to be pretty wide, right?
It's pretty wide. Yeah, it's going to be pretty wide. All right. Okay, there we go. So, there's my vertex. Sketch the graph. What has happened to it? Well, which way did it move this time? Moved right 1. Okay? Now, not only has it moved right 1, but we got to deal with this 1/3. Okay? So, you could just simply write vertical stretch of 1/3. Okay? That's what's happened to it. Okay, mathematically. But, I already said it gets wider. Gets wider. Great. Great. Okay. I mean, you know, that's what we want you to know how to do. Okay. You don't have to verbalize it in all this mathematical stuff. If you understand it, that's all that counts. Okay. So that's those problems. Questions on those ones? I mean, vertex and sketch, I feel like you guys can really hammer that. Well, because the A value here, remember we did some sliders with that, right? And one of the things that we said was when this is a number, this is 0.3 of a decimal, right? So when it's between 0 and 1, it takes it and kind of stretching it out this way. So it makes it wide. Okay. So if I take and do one like this, okay, something like that, then I'm going to get a really, really wide curve. Okay. Whereas if we do something like this, okay, then you can get a really narrow curve. Okay. Okay. So this number is affecting that. I think it was 3, it said make it thinner and wider. Okay. All right. Thinner and wider. Okay, but, yeah. And if it's negative, then it's going to flip it. Right. So we have U versus not U. Ends. I don't know. Good questions. Any more? And the activity we're going to do in the lab is going to really help you with this. You're going to have. I think you'll have fun with it. You'll get it all figured out. The only other one they have you do is one like this. They say the vertex is, this one for example is 41. I don't want that. This is 40. This is 41. Okay. And it says, write the vertex form of a parabola that satisfies the given conditions, then write it in general form. So it says, write the vertex form and then write it in general form. And it says the vertex is 3, 4, and A is equal to 3. Oh, okay. So I'm going to write it in vertex form first. A is 3. X, what are we going to put inside here? X minus 3 squared plus 4. There. I wrote it in vertex form. I satisfied that part. Now they want me to write it into general form, which is the exact thing that we were just doing in the beginning of this seconds. After you came back from break, I shouldn't say just doing. Okay, so remember what we want to do. Write this twice. And then FOIL. Okay, 3, 3. Distribute. Plus 27. Add the 4 on at the end. Okay. So that's just a fancy way of saying convert it to general form. That's what they did. Okay. They could have said that, but they didn't. All right. They made 3 lines into that. All right. So that is pretty much all there is to. You're just converting back and forth on most of those and comparing graphs. All right. I think you'll be fine with most of that. Okay. So now you can see the kind of thing I can ask you is to give you one in general form and say, hey, can you write this and tell me what the vertex is? Write it in vertex form. Give me one that's a little thinner. Give me one that's flipped upside down. That kind of thing. All right, and you can just do that part. Okay. Questions on any of that stuff? That's 6.2. The only thing different from, I know like Aaron took 65 with me and we didn't do completing a square, right? But that's the only, everything else we've done so far is pretty much the same thing. All right, 6.3, whew, finally get there. You're not going to have any problem with this either because they're solving these and we've solved some of these before, and you've always told me we should use the quadratic formula. And I said, yeah, you're right, but you're not supposed to know that yet. So guess what? Here we go. Solving quadratics, okay, we're going to talk about using the quadratic formula. So, basically, there's a couple ways to solve quadratics. Graph, using Desmos, okay. Factor, which is what you've done before, and even in this course. Completing a square, which I'm not even going to mention because it's, like I've already told you, it's a waste of time. And the quadratic formula. Okay, even though I'm writing it backwards. Formula, the quadratic formula should be switched. Alright? So, what I'm going to have you do then for me is I'm going to give you some to solve, and I'm going to say verify your answer graphically. So that's how I'm going to teach these ones. Alright, exactly how I would ask you on your test or quiz. Alright, first of all, let's talk about the quadratic formula. Most of you have told me about this already, so I know that you know it. We'll write it down. There's a way to derive it, but I really don't think that is important for you, I guess. If it was something you wanted to know, I can show you. It basically comes from completing a square. And it's not hard to derive it, but here's the formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Right? You know, it's something that, yeah, you probably should memorize it, but people go, why memorize? Hey, after you've done it 10 times, you memorized it. Okay? I mean, it's just there. You won't have any troubles. All right? That's a quadratic formula. Factoring, we've already done. The problem is that factoring works for a very, very small sample of quadratics. Probably about 10%. Okay, graphing works with all of them except for one certain type. Alright, so you can type it in Desmos and get an answer also. They do talk about completing a square in here for solving these, but I don't. There's one section that says that, and if it does, just use the quadratic formula. Just ignore it completely. Alright, I really don't think anybody's going to say you got to solve these by completing a square. You know how to do to complete the square, so there's no reason for it. Just use the quadratic formula. Okay. I might have stayed away from even giving you those. Alright, so let's solve some. Okay, so let's solve this. We're going to go x squared minus 8x. I got to make sure I do this right. Minus 10 equals 0. Let's see. 4 times. No. Yeah. Is that going to work? Yes. Okay. Alright, so we're going to solve these. Okay? Again, I could type this in the Desmos and graph it, but I'm going to teach it as if I'm going to ask the question. So, guess what? Can't factor it because 10 is going to be 2 and 5 and 1 and 10, and none of that's going to give me 8. Alright? So I can't factor it. That's out the door. I got to use a quadratic formula. If you don't know, if you've never done this before, alright, here's how it works. This is A, B, C. We've already kind of did some stuff like that. So A is 1, B is negative 8, C is negative 10. This is a 3-point problem. I would give you half of the credit if you just did this right there. Alright, because you're telling me you know what A, B, and C are. You just, for some reason, don't want to use the formula. So, or you don't remember it. Alright, here we go. Negative B. So, when I do these, alright, I like to just put 8 there, because that's what opposite of 8 is anyway. Negative 8 is just positive 8, plus or minus square root. You can show as much work as you want. Okay? I'm going to go through this pretty slow right now, just because I'm going to assume that some people may have never seen this. Alright, although I think most of you have. I like to take the B and square it in my head. Okay? And I'll show you why when we do it on a calculator. And 2 times 1 is just 2, so I do that in my head too. All right, here we go. 8 plus or minus square root 64. I have a minus 4 times 1 is 4 times 10. That's a plus 40. Okay, so I'm plugging the numbers in. I took b and squared it in my head because that's what I like to do. 4 times 1 times negative 10. Now, we're going to finish this off here by doing and adding these up and going like this. Okay, most of the time I'm happy with this number. All right, you might say 8 plus or minus square root of 104 over 2. All right, how can you be happy with that? It doesn't really tell us anything. All right, but we want an exact answer. We'll put it, or not an exact answer, but an approximate. We'll put it in the calculator. Okay. Some of your mathematical purist teachers are going to say, well, 104, if we should break that up, so we should find a perfect square that goes into 104, and let's see if anything does. So I think 4 does. 4 goes in there, let's see, twice. That's going to give me 24, 26 times. So I can break down 104 into 4 and 26, which means, you know this because you took a test on this, 2 times 26 goes in there over 2. Square root of 4 is 2. 26 stays because I can't do anything with it. And then we can divide these. All right. So, you check the answer in the back of the book, that's what it's going to give you. All right. However, these two answers are the same. They're not any different. This one's a little more simplified. Okay. You've already proven to me that you can break these down, so I'm not too interested in that. You can take that further. So for me, I'm happy right here. Okay. Some other people are going to be happy right there. So if you're looking at them in the back of the book and you're getting different answers, that's why. You're going to break it down. Okay? Now, so my question would be, solve it, graph it for me, and verify your answer. So now we're going to graph it. We're going to use Desmos. I wish I could just switch into this, but I got to pop out of here, but I'll come back. Some of you might be writing it down. Here we go. Let's go back into this. All right, clear this out, out, and out. So I'm going to type this in, y equals. Now I'm going to type in the original equation. Don't type in the quadratic formula. All right, I've seen that happen though. People will type that in, 8x minus 10. Okay. So here's the graph of it. The x-intercept is going to be the answer, so one answer should be negative 1.099. The other answer should be 9.099. All right, that's way different than 8 plus or minus a square root of 104 over 2. But if I come down here and type this in, parentheses, 8 plus square root 104, okay, divided by 2, 9.09. If I come up here, click on that plus, make it a minus, negative 1.09. Alright, so yeah, this graph checks with my answers. Right? The difference is an approximate answer versus a complete answer there, an exact answer. So, here's my graph. Yep, there's my x-intercepts. They match. That's what I'm looking for. All right. Now, if for some reason this graph and these answers don't match up with this, then there's a mistake somewhere. All right. So, it allows you to check. And I think we talked about this once before. If you think, if there's something wrong, and your answers aren't jiving, and you tell me, my answers aren't, I don't know what's going on. I'm going to be real kind on that as far as marking things correct or incorrect, because you're telling me you know something's wrong, you can't find it. And I think that's really important. So that's the kind of thing I'm going to ask you. Okay? Solve it, verify it. Solve it, verify it. You always have to make sure that the equation is set equal to 0. The book will sometimes have the equations and they won't have them set equal to 0. You just got to rearrange them so that they are. They do more of the quadratic formula than 6-4, but I'm doing it today. Let's see this. Okay, here we go. A, B, C, 3, 2, -6. Alright, so let's use it. X equals negative B, oops, negative B plus or minus square root B squared minus 4AC all over 2A. So what are we going to write up here? What do we get for B? So we're going to go negative 2 plus or minus. Okay. B squared, so that's going to be 2 squared, so that's minus 4 times, what's A? And C is? Good. And that's just going to be, oh, that's going to be 6 this time. All right, 2 times 3. Okay, here we go. Now you can type this in the decimal straight up and it will give you an answer, by the way. But it's not going to give you an exact answer. And again, you show as much as you want. I'm showing a lot more than I probably would. 4 times 3 is 12. Ooh, I need 12 times 6. 72. Put a plus there. Put a 6 there. Over 6. Okay, so there. I'm happy with that, right? You don't have to break it down, but if you check your answer in the back of the book, they will break it down. So that's completely up to you. All right, we should verify it by graphing. Okay, so you should go into decimals. You can do that. I'm not going to do it because I'm going to pop back and forth, but if you did, number 1, you should get 2 places it crosses. So I'm going to guess that it crosses 1 negative, 1 positive. I'm just guessing. I could be wrong though, because it is a 3 for a... Anybody graph it yet? See what it graphs and what it touches? Okay. Okay. So that's probably not a very good sketch then. It's pretty thin. There you go. Something like that, anyway. Alright. That's awesome. So, yeah, that's a quadratic formula, which I think a lot of you have already done before. And it's again, they're going to do it in 6.4. We're kind of doing it in 6.3. Because wherever we see the word complete the square, we're going to ignore it, and we're going to solve them using the quadratic formula. Now, they do have some that are written like this. Oops. Okay, and the title is Solve by Square Root Property. Okay. You can still use the quadratic formula on this if you want to. Alright? It's up to you. The only thing here, A is going to be 3, B is going to be 0, C is going to be 25 because you have no x. Alright? It's all going to work out to be the same. The square root property, though, goes like this. So we would add 25. Divide by 3. X squared equals 25 divided by 3. Now, since this is a square, I want to square root. Square root. Square root of 25 is 5. Square root of 3 is that. This is where I would take points off. You can't have a square root in the bottom. You have to rationalize it. Alright? 5 square root of 3 over 3. But because you're squaring and because it is a quadratic, this is going to have a plus and a minus for an answer. So make sure that you put the plus or minus in there at the end. Okay? Quadratic formula is going to give you that exact answer. Right? Because b is 0. So it's going to give it to you just like that. So I really don't care which way you do it. Alright? Because to be honest with you, most quadratics are solved using the formula anyway. Or graphically. So you can choose your way. So on this whole 6.3, you can use the quadratic formula on it. Alright? Give you any of those ones. Yeah. There are some where it says solve symbolically, graphically, numerically. Just skip the numeric part because that's using a table. Just solve it. Quadratic formula, solve it graphically. Okay. You're just going to verify. I don't care about the table part either. Because again, it's hard to generate tables and get those answers. Solve by factoring, we've done. Would look something like this, and we just factor it, right? 2 and 10 is our magic number there. X minus 10, and we've done this, so x equals 10, and x equals negative 2. All right. So yeah, that one works because that's they set it up to work. All right. Alright, so I don't care again how you solve these. You can use quadratic formula, would be best. Okay, don't follow the directions on there. Just solve them using the formula. It's just the best way to do it. Questions on that part? Awesome. Okay, so this is what we're going to do the rest of the time. Ryan, I'm going to give you time to work on your assignments like I always do. Then in about an hour or so, we'll trek on over to the lab, and I want to do this little thing with you that I still think you're going to kind of like that. It would be a Desmos activity. And then we're done because we have no quiz even though this thing says we do. And that's it. And if you have questions, make sure you ask.